Okay, in section 4.4, we're going to look at finding slope and rate of change. Again, ideas that are hopefully going to serve as a review for you as opposed to something that's brand new. Okay, so remember, we use M for slope, and the ratio of the vertical change, the rise, to the horizontal change, the run, is called the slope. Okay, so you can think of this as rise over run. Okay, and that's the same thing as saying the change in Y over the change in X. Okay, same thing. Just make sure you're consistent there with X2, X1, Y2, and Y1. So it says the roof of an entryway to an office building has a rise of 40 and a run of 100. What is the slope? M equals rise over run. And then simplify. 20 goes into both of those. 20 goes into 40 twice. 20 goes into 100 5 times. So the slope would just be 2 over 5. Up 2 over 5 is the slope. Okay, now, when you're finding slope here, you can use the formula, or the easier way, in my opinion, is just to count. So I got to go from this point to this point. I got to go up. 1, 2, 3. And then from there, I got to go right. 1, 2, 3. Up 3 is positive, so the rise is 3. And the run, if I go right 3, that's also positive. 3 over 3 tells me the slope here is just 1. In part B, again, rise over run. Okay, so I got to go from this point now to this point. I got to go down 1, 2, 3, 4, 5. So down 5 is negative 5. And then I got to go right 1, 2, 3. So that's positive 3. And so your slope is just negative 5 over 3. Okay, part C here. Any horizontal line, right? If I want to go from this point to this point, I don't rise at all, so my rise is 0. My run here is 1, 2, 3. 0 divided by anything is always 0. So horizontal lines have a slope of 0. Vertical lines, you'll notice here, if I rise, I go up 1, 2, 3, 4, 5, 6. My rise is 6. My run is 0. Anytime you divide by 0, that is undefined. Okay, so horizontal lines have a slope of 0. Vertical lines have a slope that is undefined. So just really quick to classify lines based on their slope. A positive slope will rise when you go from left to right. A negative slope will go down from left to right. 0 slope is horizontal. Undefined slope is any vertical line. So there's kind of a summary of the different types of slopes. Those are the only slopes you can have: positive, negative, 0, or undefined slope. Okay, it says plot the point, draw the line through them. Without calculating, tell whether the slope of the line is positive, negative, 0, or undefined. So 1, 0. So 1, 0 is right there. And 5, 3. 5, 3. Draw the... Whoops. That was not very accurate. If I draw the line that passes through those 2 points, clearly that line is going to have a positive slope. Okay. I'm going to go ahead and let you take a look at the other ones. Those are pretty straightforward. You just plot the points, compare them to what we did right above that, the classification, tell whether it's positive, negative, 0, or undefined. Okay, that's just a continuation. It says find the slope. So now we're going to use formula, the slope formula. So M equals x2, y2, change in y, so y2 minus y1 over x2 minus x1. It doesn't matter which way you look here, okay? You got to subtract your y coordinates. So if I do 3 minus negative 2, then on the bottom I have to start with 0. So 0 minus 5, okay? If you started with negative 2 on top, then you'd have to start with 5 on the bottom. So 3 plus 2 on top is 5. 0 minus 5 is negative 5. And 5 divided by negative 5 is negative 1 would be your slope. Part B, change in y over the change in x. Subtract your y coordinates. Negative 5 minus 4 over. Now subtract your x's. Again, you started with negative 5. So you better start with negative 6 on the bottom. Minus negative 1. Negative 9 on top. Plus plus. Negative 5 on bottom. And so the slope here is positive 9 over 5 because they're both negative, so 2 negatives become positive. All right. Again, I'm gonna leave the last 2 there for you to take a look at. Same formula: change in y over the change in x. Subtract your y coordinates, subtract your x coordinates, and then simplify that ratio. All right, example 5 says find the value of k. So the line through points -3 comma k and 1, -4 has a slope of -3/2. In other words, change in y, so here are my 2 points. If I find the slope there, the change in y would be k minus -4 over change in x. And we know what the slope is. The slope is -3/2 equals k plus 4 over -4. And now we have a proportion here. We got to cross multiply. When I cross multiply, -3 times -4 is positive 12 equals, distribute this 2. So 2k plus 8. Subtract your 8 from both sides. So you get 4 equals 2k. Divide by 2. K equals 2. All right, so again, just more of an application type problem of slope. Again, example 6 is the exact same type of problem. You're going to use that to kind of see where you're at with this stuff. And if you want to go over that tomorrow in class, we can do that. If not, that's fine too. Okay, so the last thing we're going to discuss here in this video is rate of change. A rate of change compares a change in one quantity to a change in another quantity. You can interpret the slope of a line as the rate of change. Okay, you can also compare rates of change by comparing slopes. So, it says find the rate of change in cost with respect to time. So the rate of change is the change in cost over the change in time. Pick any two that you want. We'll just use this guy and this guy. So the change in cost would be 21 minus 14 over, and then the 6 minus 4. Got to match up. So that's 7 over 2. So what that means, okay, is that for every $7, or I'm sorry, for $7 for every 2 hours is what you're getting. Okay, $7 for every 2 hours is what that rate of change tells you. And then finally, if I look at this graph, it says describe a student's commute home. So this is the amount of time they're taking, and this is how far they're going. Okay, so you'll notice over the course of this first stretch, they're just kind of steadily walking at a steady pace. All right, they're walking, they're taking their time, they're going, they're gaining ground every step of the way. But then you notice from here to here, time is elapsing, but they're not gaining any distance. Therefore, that means they're standing in the same spot. And then finally, the last stretch from here to here, they're walking at a very high rate of speed because they go a long distance in a short period of time. And that's kind of how you would describe that. That's just interpreting a graph and slope. So again, this video should be pretty elementary for you. The slope formula should be familiar, and hopefully most of these ideas, are just kind of more of a refresher than anything else. So as always, bring questions to class, and we will address those first thing.